Hey guys, welcome to our next episode of Kubernetes Happy Hour. Today we have a pretty cool subject where we talk about how we're going to create a pod and watch the kubelet come in and kill our pod. So we're going to talk about, in Kubernetes today, we're going to talk about resources. So every pod in Kubernetes, you have the ability to go in and define the amount of resources, CPU and memory, that a pod can consume inside your cluster on the node that it's running at. There's two levels of definitions that you can define for resources. One is the request and one is the limit. So the request is kind of like a guaranteed commitment of resources that the scheduler is going to give you on a node. It's going to be CPU and memory. So you can request a tenth of a CPU, and you can request 200 megabytes of memory for your application. And then you can define a separate limit, which is kind of a hard ceiling on the amount of CPU and memory that you can request for your pod. So what we're going to do today is we're going to mess with those settings, and we're going to trigger the add memory killer to come in and kill our pods. And we're going to show you how the kubelet comes along and maintains order on the node to make sure that a pod running on the node doesn't consume any more resources than what we've defined for it. So this is kind of a key thing in Kubernetes and the scheduler and the kubelet working in tandem, making sure that all the pods that you have deployed into your cluster are behaving correctly. So this gives people the assurance that when they deploy their pod into your cluster, there's no noisy neighbors. They're not going to get starved by other pods that are running within the same node on the cluster. And it'll show the guaranteed resources that get given to a pod. And if we have time, maybe we'll go into see how things get throttled. When you go above your request limit, but below your hard limit, there is a period in between there where the pod will get throttled from a CPU and memory allocation perspective. So given all that, so let's jump into what the resource definition is, and I can show you guys like how to set that up in your deployment. So let me go over here and go to my terminal. And before I do anything, let you guys know beforehand I set up some deployments. So this should be in my directory here. We have a deployment guarantee. So let's open this guy up. I made an application called test v2. And I put it on my Docker repository. Let me increase the size of this guy. So this MRL35 here, this is my Docker Hub repo, my public repo. And v2 is the tag that's on the application called test. So I made an application called test, and I'll show you what that actually is in a second. Okay, so this is the important part right here. Inside your deployment spec, you have a spec section for your containers. And in here, you can specify how much resources every container is supposed to consume. So the request here, this section right here, this means that when the scheduler goes to find a home for your pod, it's going to assure you that this amount of resources is committed to your pod. It can't be shared with any other pod. This amount of resources is guaranteed to be associated with your pod. So we're going to get 60 millionths of a CPU, or 60 millions of a CPU. Which is really 60 thousandths, not millions, 60 thousandths of a CPU. So one CPU is equal to 1,000 millis. You could just put a fraction here, or you could write out 60M, or you could write out 0.06. So memory here is 300 meg. Gigabytes is GI. So we're going to say 300 megs for a request. So when the pod comes up, we're going to be guaranteed this amount of resources. The limits up here, which is the hard limits, which is going to be how I'm going to demonstrate to you the add memory killer, is if it goes beyond, if your application, if your container grows beyond the 300 megabytes, it will get killed. So I'll demonstrate that to you. Okay. So this is an optional section. You don't have to fill this in. And if you don't fill it in, it introduces something called a quality of service. So the quality of service is when the actual pod is running, you have three different classifications for the quality of service. You have best effort. Now, best effort means we didn't fill in the resource section. So Kubernetes is going to make a best effort to schedule your pod onto a node, and it doesn't have any guaranteed resources. So there's a very good chance that it will get evicted and put somewhere else. There's the second quality of service is called guaranteed. So guaranteed means that the resources that are allocated for the pod are guaranteed, and the pod will not be evicted because they're guaranteed. I'll show you how to set up a pod to have a guaranteed quality of service. So we have best effort, we have guaranteed, and we also have burstable. Now, burstable is a scenario where your requested resources are set to a certain level, and your hard limit is above that requested limit. So you're allowed to burst up to your higher limit, from the request up to the higher limit. That's called a burstable quality of service. So the order of precedence for things when they get evicted, first the kubelet will look for pods that are best effort. Those are the first ones that get evicted off of a node. The second level of quality of service that gets evicted is the burstable. And the third, and should never get evicted, is the guaranteed. So guaranteed, the way that works, guaranteed in specific, is your request matches your hard limit. So if I request 200 megs and a tenth of the CPU, and my limit is 200 megs and a tenth of the CPU, I'm guaranteed that 200 megs and a tenth of the CPU. So let's get into it. I'll show you guys what I mean. Let me go over here. Let's deploy my application. I'll show you what the application is. It's just nothing crazy. It's a Python script. And the Python script is just going to create a big string, and it's going to consume a lot of memory. So I just made this thing to set up to trigger the out of memory usage. Okay. So let's look at our deploy guaranteed. We're going to do guaranteed quality of service first. So here's our guaranteed. You can see down here that the request parameters match the limit parameters here. Okay. And I'm not going to kick off my script. So when the container starts up, it's just going to issue a sleep, and it's not going to do anything. So let's run this. Kubectl apply. So again, I created a cluster before I had this demo. My cluster is of size 3. I have one master, and it's running in Amazon. I used kops to do that. You should watch my demo from last week to learn more about kops and how to set up your cluster. So let's look at the pods I just made. Get pods. Okay. Actually, it didn't actually deploy it because before this I deployed the same thing. So let's do this. Let's change something here. Let's change the termination grace period to 31. That should do it. Okay, so what I just did is I triggered a rolling deployment of the new settings for the deployment, because anytime you change the spec for the container and anything in that section, it will automatically roll out the changes for you. So I have my new guy here, and if I look at him, if I do describe on the pod, you'll see the quality of service on this guy. Okay, describe. I forgot the word pod. So you want to describe pod. So you can see here the quality of service is guaranteed. This is the description of the pod. It's guaranteed. So let's play around with this guy. Let's go into the deployment again. and I'll show you guys how to make this burstable. So burstable would mean that my limit for the memory would be more. Let's say we're going to make this 300, right? So we're going to say we can burst up to 300 millis of the CPU and 500 megabytes for the image. So let's roll this and I'll show you guys. Now let's do get the pod, so I can get the pod. You can see it's creating a new pod because I changed the section for the container, and it's going to roll it out. Let's do describe on the new pod. You're going to see the quality of service change. So the quality of service now is burstable, like I said it was. So burstable means that we can burst up to the limit, but not beyond the limit. If the memory goes beyond the limit, it will get out of memory killed. Okay, so let's do the last one where we don't define it at all. Let's go into our YAML file again. And we're going to take out this whole section. I'm just going to take out the whole resources section. Okay. And now we're going to deploy this guy again. Okay, let's get the pod name so we can describe it. Okay. Describe pod. So now would I expect the quality of service to be best effort, because it just doesn't know. It's just going to give it its best shot, and whatever is going to happen is going to happen. So obviously you don't want to actually do this. It's going to say quality of service burstable. I wonder why. Let's see. It's doing. Do I have any resources set? We can go circle back on this. So we got that. The requested CPU is 100. I wonder why. Did I skip that here? Let me go into here again. Did I say 100 somewhere? No. Unless there's a default. There may be a default. So this is what we're going to do. We're going to do it the hard way. We're going to do edit deployment on the test API. Okay, and we're going to go down here. And we're going to search for the resources, right? And they're empty here. Okay. Okay, so anyway, if you don't define the resources, what's going to end up happening is going to be a best effort. Okay. I wish it said best effort because the demo gods are not smiling at me right now, but trust me in that it's a best effort. Okay. So let's actually do something interesting here. So we have our pod. All it's doing is sleeping, right? Kubectl. Oh, I know what I did. I think I know what I did. Let me get the pods. Did I do it on the old one? Describe pod. 5D. Yeah. Okay. Okay. So let's move on. I don't want to get hung up on that. Maybe if we have time at the end of this, we'll circle back and see why it doesn't say best effort, why it says burstable. Okay, so let's actually do something interesting now. Let's demonstrate the out of memory killer. Deploy.yaml. Okay, so this deploy.yaml actually runs our Python script, and you saw our Python script before. What it's going to do is it's going to consume as much memory as it can by making this big long string in a loop until it actually runs out of memory. So here you can see I'm asking for a 256 megs and then be able to burst up to 300 megs. If it goes beyond 300 megs, then it's going to get killed by the out of memory killer. So which is what the whole point of what I wanted to show to you guys is. So let's go into, let's deploy this guy. Apply YAML. Okay. So let's look at the pods. Okay. So So let's watch this guy. So we're gonna wait for the restart to happen. This guy's running that Python script, and what's happening is it's growing and growing in memory, and eventually the kubelet is going to detect that the memory consumption by the pod has grown beyond what it's allowed to consume. And basically how that works is kubelet, I guess, uses C advisor to do that, and you can see there it is. So this is the event, OOM killed. So this is what you're going to see a lot if you have an application that has a memory leak. Kubernetes will come along and detect that the memory has grown beyond the limits that you set for it, and it will kill it, and it will restart it. So this will be in a loop forever, because you'll see what's going on is the pod will get killed by the kubelet, and then it'll get scheduled again to run somewhere else, because in my deployment I say I always want one of these things running. So it'll kick off again, and then it'll get killed again, like this. And this will be in a loop until the cows come home. So it's always good to have monitoring in place to let you know that these restarts are happening, so you can take action on them, right? Okay, so let me show you how you can tell something has been OOM killed. So if you do a description on the pod now, you can see describe pod, bud test, blah blah blah. Oh, it changed on me. Did it change on me? That's what I done. Okay. Let's see. Kubectl get pods. Yeah, put in the wrong one here. When you do a watch command, a -w, it'll watch for all events related to, what did I do? On get pods. So I guess some of the pods transitioned that were not the ones that I care about, and I was notified of them. Okay, so this is what you look for. So you got some history here. Okay, the last date. This reason OOM killed this right here at exit code 137. This is the smoking gun that the OOM killer has come along and killed your pod. So this will be in the logs for Kubernetes itself. This will also be apparent if you're using something like Prometheus. So Prometheus can be configured to alert on pods that are restarting in your cluster. Okay, so let's go to get the pods again. Actually, no, let's edit the deployment so we can stop this loop from happening. Okay, so this is test API. So we're going to go in here, and I guess the startup command, we don't have to run this startup command anymore. Where's the command? There it is. Okay. We can say change this to sleep again. And how long we're going to sleep for? We'll sleep for a whole long time. Okay. You know what I'll just do? I'll just do... Because it didn't like that because I didn't put quotes around the arguments, but I'm just going to do the guaranteed, which is just sleep one again. Okay, so now we got our pods running. Okay, and this one's not going to restart. You can see that it took about a minute for it to consume all the memory before the OOM killer kicked in and killed it. This is the new one. Let's copy the new one. Let's do describe. So this guy should be the guaranteed guy, right? Or we changed guaranteed to be burstable, so he should be burstable. Kubectl describe pod. Okay. Unknown command kubectl for kubectl. Oh, I kubectl twice. Okay. So this guy is going to be burstable. You can see here. like that. So let's go. Let's circle back now. So what I showed for you, and at the end of it, I'm going to try to set up the best effort. I'll try to show you that quality of service class best effort. I'll show you how to set that up. Okay, so what I wanted to show to you, and I think I want to show you to you, is how when you define the resources, it influences the behavior of your pod. So if you set it too low, the out-of-memory killer is going to come along and kill your pod. If you set it too high, it's really a waste of resources, because if you request more than you need, then other pods don't get those resources. So you don't achieve the density that you possibly could obtain inside your cluster. Let's say, for instance, that you request 200 megs and your application only needs 10. That could have been 190 megs that could have been used for other applications. Or, moreover, you could have run that same pod 20 more times on the same node, right? With the resources that you're wasting because your request limit is too high. So it's very important to do the right engineering to figure out how much resources your application really needs to achieve that optimal density inside your resources, inside your herd of nodes out there. Because without that, you're not gaining all the benefits of running your application inside Docker, inside Kubernetes. So it really behooves you to go and figure that out, to sit down and trace how much CPU and how much memory your application really needs. And if you do that, and you have sane limits for your hard limit and your resource request limit, then maybe you do want to see if there's a memory leak, right? And if that sweet spot is set where your pod's restarting because there is a memory leak, and you have a learning set up, then you can know right away that your application is not behaving nicely, it has a memory leak. But the saving grace is that since Kubernetes is so resilient, you could actually run with a memory leak forever if you wanted to. But you suffer from the fact that your pod's going to get restarted by the OOM killer. So when the OOM killer kicks in, if your pod is part of a service, I think what goes on is that the traffic is, the pod is removed from the service seamlessly. So if you have two pods running, then what can happen is one will go down, the other one will stay up. Now you may run into a scenario when you have two go down. So it's really important to have your memory leak actually fixed for that reason. Is that if you have multiple instances behind a service, there is a chance that the memory OOM killer could kick in at the same time for all of your instances. So you don't really want to be running forever in a scenario where you're getting OOM killed. You want to fix your memory leak so that scenario doesn't happen and you don't have an outage. So let's go back here. Let's go back to my terminal, and what I'm going to do is I'm just going to do a quick search because I do have some time. I pretty much showed you guys what I wanted to show you guys. So the quality of service in Kubernetes for best effort is supposed to be set up when you don't define the resources. So let me see. Create a pod. I mean, this is on the Kubernetes documentation. So, okay. And so basically, if I set up a pod that has no memory or CPU limits, then what we should see is a best effort. Okay. So let me try this again. Let me go back to, I think what the screen you guys are seeing is actually my terminal. It is. So let's do this. Let's open up and deploy that YAML, right? We have the image pull policy, and what we're going to do is we're going to get rid of all the resources. We're going to get rid of the rolling update, the strategy. I don't think that's part of it, but let's do this. Let's get rid of the resources. Let's change this to the sleep commit. Before I was telling you the sleep, when I put in the sleep and I tried to edit the deployment, I didn't put in the quotes, and that's why I was complaining. Restart policy always. Take this out. Take all this stuff out. Okay.
Left over 4, double backslash, left over 4.
Okay, so this is pretty bare bones. So let's see what this does. Kubectl apply. Deploy YAML. Okay. So let's see our pod. We got a new pod there. Let's describe the pod. Hopefully this guy says best effort for the quality of service. And if not, then I'm going to have to circle back and get back to you because it says burstable still. And it says burstable because you know what here it says request CPU is 100. I wonder where that's coming from. I wonder if there's something built into my cluster that, so I spun up a cluster before this using COPS, and I'm wondering if COPS has like an emission controller that's always setting requests for the CPU to 100, no matter what. And because it's doing that, then let's see. Let's see what we got. Do we got emission controllers? But this is Kubernetes version 1.8. Let's see. We got. I don't think there's any admission controllers set up. Anyway, so I will research this and I'll come back to you guys next week. I don't want you guys to hang out while I'm just doing Google searches on the side or going into COPS in the source code to figure out why the 100 meg is. I'm suspecting it's an emission controller. Something set up where when you introduce resources, when you introduce pods, if there's no resource limit set, then it's automatically setting one for us on our behalf, which is totally possible, which is probably what's going on. And it's always going to say burstable because that setting will always be there. So if you didn't have any settings, if there wasn't something in between setting that resource limit for me, it would say best effort. And the point being is it's not really important. Just know that if you don't set it, it's going to be best effort. And best effort is bad because if you have a pod that you care about and it's best effort quality of service, that's the first one that's eligible to be evicted. So eviction means there's not enough resources on the node anymore, and you have nodes that are consuming beyond what they've guaranteed requested for. So the guys that are best effort go first, the next guys that go are the burstable, and then the next guys that go are the guaranteed. But guaranteed usually stay because they're guaranteed, right? They're guaranteed to have those resources that are on the node. So another thing to notice that in the burstable, it really is burstable. So when it goes beyond the requested limit for CPU and memory, it's in competition with everything else for the remaining memory and CPU that's available to the pod. So let's say, for instance, your request is 100 megabytes and your application has grown to 150 megabytes in size, and the limit is 200 megabytes. So you're within your zone of not being OOM killed, right? Because you're under the 200 meg limit, but you're at 150 megabytes. So if the node ever ran out of memory, that pod that's at 150 is going to be OOM killed because it's not guaranteed past 100. And moreover for CPU. So if there's a competition for the CPU, your pod will suffer in that it will be throttled for access to the CPU. So you actually see this a lot. We see it a lot with Java applications running in containers. So Java applications, Spring Boot, they will consume a lot of CPU when they start up because it's so class path heavy. When Java looks into the class path to discover auto configurations and other reflective classes, is very intense on the CPU. So that first couple of seconds of the application coming up is very CPU intensive, and then usually it just drops off after that. But what we'll see is the first couple of seconds where the CPU will be throttled for the application. Okay, so that's it for today. I just wanted to show you guys something quick and simple. And next week we're going to take on something a little bit more complex. But I hope everyone has a great weekend, and I'll talk to you later. See ya.